What you first need to do is identify that volumes are equal. Okay, so let's find the volume of this box B. So the volume formula for a prism is capital B, capital H, where capital B represents the area of its base. The base is a trapezoid, so we'll use the area formula 1/2, sum of the bases, times the height of the trapezoid, all times the height of that solid. So if we fill in the values that we have, okay, what we're looking for is this length. So when you're looking for the sum of these two bases, we need to be able to figure, can we find what this upper length is? Well, the height of this trapezoid is 8. The side length is 10. And so what kind of a triangle are we dealing with here? We have 8 and 10. They both share a common factor of 2. So this is 2 times 5, and this is 2 times 4. So you have a blank for 5. So what does this leg have to be? 3 times that multiplier of 2. So the whole thing is 6, which means when we look at this other portion over here, this length is 6. And so what's left for this middle portion? Also 6 from the whole thing of 18. So we can now fill in our pieces. The base 1 is 6. Base 2 was 18. The height of our solid was given as 8. And the height of the whole solid itself is 22. And so we can multiply this through and come up with our total volume. So if we take 1/2 of 6 plus 18 times 8 times 22, 2112 is our volume. So that means that this figure is going to have the same exact volume. So here we have a prism also. So the volume formula for a prism is still capital B times capital H. Capital B we're not sure of, okay, but capital H is 15. And so if we plug this in, we know that their volumes are the same. So we can plug 2112 in here, divide by 15. And so we know that 140.8 is what our area for this base shape has to be. And now we can go to that base shape. The base shape is an equilateral triangle. So I'm going to rewrite it right here. Because the area formula for an equilateral triangle, if we were to draw this in, okay, what kind of triangles are created when we draw in this altitude here? 2 30, 60, 90s. So this is 30 degrees, 60 degrees. Okay, and so if we were just to put these in terms of, let's say, x, let's call this x. If this is x, what's the height going to be? Using the properties, special properties of a 30, 60, 90, we have x, 2x, and x root 3. And so the area formula for this triangle right here is going to be 1/2 base times height. Well, what's the length of our base here? The whole length is 2x. And our corresponding height, x root 3. And so in terms of this length here, the 2's cancel. We get x squared root 3 is the area formula. And so if we plug this back in right here, we can find what our side length is going to be. So if we take 140.8, set it equal to this area formula, x squared root 3, and then solve for x, that's going to give us the length, or this portion of the right triangle length. So if we divide 140.8 by square root of 3, and then we take the square root of that whole thing. So we divided by root 3, and now we're going to square root that entire quantity. So if we take the square root of this number, We get the length of this portion, 9.02 approximately, which means what is the length of this side here? What do we have to do to the number in our calculator? We have to double it. So if we double this, now we have the length of each side, which is approximately 18.03. And so now we can solve for the surface area, right? The total surface area is 140.8 for the top, 140.8 for the bottom. So we're going to take 2 times 140.8. And then we have how many of these rectangular faces here? Since it's an equilateral triangle, all 3 of those faces are exactly the same. So we're going to add to that 3 times the base of this 18.03 times the corresponding height of 15. And so that total sum will give you your surface area. And I'm not going to calculate that through. You've either found it by trial and error, or you can do the calculation on your own. But you'll just add up all those pieces.